Hi dear students, so we have already discussed the Newton's first and second laws of motion. Now we are going to discuss the Newton's third law of motion. The statement for the Newton's third law of motion is that to every action there will be always an equal and opposite reaction. That is the statement for the Newton's third law. So for every action there is equal and opposite reaction, where the action means a force. So every force there will be an equal and opposite force. For an example, the recoiling of the gun. At the time when you are firing the bullet from the gun, the gun is actually exerting a force over the bullet. That's why the bullet is moving with a particular acceleration or a particular velocity. And the recoiling, that will be at the time of firing, there will be a backward motion over the gun. Otherwise, there will be a force which acts backwards on the gun. So the bullet is moved by the force exerted by the gun over the bullet. At that time, the recoiling was due to the force exerted on the gun by the bullet. So there are equal and opposite forces. So recoiling of the gun is one of the example for the third law of motion, Newton's third law of motion. Likewise, if you are considering two bodies A and B, suppose a body A and another body B. If A is applying a force over B, okay, A is applying a force over B, that can be represented as F B A, the force over B by A. Then there will be a reaction from B to A, that will be represented as F A B, that is the force exerted on the body A by B. So here F A B or F B A is the action and F A B is the reaction. So you can consider this FAB as action, then the FBA will be reaction. So as the FAB and FBA are equal, and you can see the direction, they are opposite. The force over B by A and force over A by B, both are equal and opposite, so they will cancel each other. So the net force over the system, if you are considering, that will be always 0. Okay, so F AB will be is equal to minus F BA. The action and reaction forces act on the different bodies, not on the same body. Okay, the first one is on the over A by B, and the next one, that is on B by A, on different bodies by the other different bodies. So according to the law, for every action there will be equal and opposite reaction. Okay, so FAB will be is equal to minus of FBA. Now in this case you don't want to consider the internal forces, because the internal forces acts as a pair inside the system, and the internal forces will be, if you are going for the net internal force, means the net internal forces, the different forces, individual forces will cancel each other, and the net internal force of a system, particular system, always will be 0. Okay, so the net internal force over a particular system always will be 0, it is because there is an action of the force due to a particular particle in that system will be cancelled by the reaction force due to the another particle of that system. So the net internal force always will be 0 in a particular system. Remember that one. Now we have to consider the next topic, that is the conservation of momentum. For the conservation of momentum, we have to consider two bodies. The PA is the initial momentum of the body and PB is the initial momentum of the body B. If they are collide each other, then there will be a force FAB and FBA. Actually the FA, we can say that the force acted upon B by A, force by A, and this one FB, the force by B which is applied on the body A. After the collision, the momentum change as P dash A and P dash B. Okay. So two bodies A and B, they are collide each other. Due to the collision, there will be equivalent exertion of the equivalent opposite forces, or the action and reaction it is happened. One it is FA and the reaction force it is FB. So as they are equal and in opposite in direction, so we can say as a vector FA will be equal to minus FB. And the change or the moment, the initial momentum, that is before collision it was PF for the body A and P dash A after collision, and PB before collision for B, and P dash B is the momentum after the collision. Now you know that the F is equal to dP by dt, the rate of change of momentum with respect to time. So if you are considering the body A, the force exerted by the body A will be equal to the change in momentum divided by time t. If the time for the collision, if you are taking that one as t, then you can see FA will be equal to dP by dPA by dt, where dPA will be equal to P dash A minus PA. This is the change in momentum of the body A divided by dt. The same way, FB will be equal to dPB divided by dt, which is equal to P dash B minus PB by dt. Okay. So here F A is equal to minus F B. F A is equal to minus F B. So as you know, F A and F B values you are having. The F A is equal to P dash A minus P A by dt, and F B will be equal to P dash B minus P B by dt. So you just substitute these values in this one. So here this one is the second law of motion, this one is the third law of motion. So by combining these equations, you can obtain, that is P dash A minus PA by dt will be equal to minus of P dash B minus PB by dt. Now dt will be cancel each other. So by rearranging the equation, you can obtain the equation as P dash A plus P dash B will be is equal to PA plus PB, where this PA plus PB is the total momentum before collision and P dash A plus P dash B is the total momentum after collision. Okay, so here the P dash A and P dash B are the momentum of bodies A and B respectively after the collision, and PA and PB are the momentum of the bodies before the collision. So you can see that by applying both the second and third laws of Newton's third laws of motion, P dash A plus P dash B will be equal to PA plus PB, where the net force will be always that is F A equal to minus of F B. So Fa plus Fb will be always equal to 0. So whenever the net external force acting on the body is 0, or the net force over the body is 0, the momentum, the initial momentum will be always equal to the final momentum. That means the momentum is conserved. In other words, you know that dp by dt is equal to F. If P is a constant, then d by dt of P will be is equal to 0. That is the F external, if it is 0, then the P remain as a constant. So if the external force value, if it is 0, net external force acting over a body is 0, then the momentum, then linear momentum will always be conserved. Okay, so remember this one. So if the external force is acting over a body, a particular system or a body, if it is 0, then the momentum, linear momentum of that particular system will be conserved, or it will be a constant. Now let us come to the equilibrium of particle. Equilibrium of particle. So in the equilibrium of the particle, it refers that a net external force, the equilibrium of the particle will be occur whenever the net external force over a particular system of particles is 0. If the net external force is 0 over a particular body, or the net force if it is 0 of a particular system, then we can say the particle is at a equilibrium. So suppose F1 and F2 are acting over a particular body, both are equal and opposite. Both are equal and opposite. Wait. Both are equal and opposite. Then, so two forces, Fa and Fb. Fb. So both are acting over a point, both are equal and they are opposite. So the net force at this point, if you are considering, that will be 0. The net force will be 0, that will cancel out. Both the A and the force due to Fa and Fb, both will cancel out and the net force will be 0. As well, if you are considering three different, at a point 3 different forces are acting, suppose A, B and C. So then this you can say as the Fa, Fb and Fc, where you can follow the parallelogram law of vector addition. That means the vector sum of Fa and Fb will be equal to and opposite to the Fc. So if you are applying the parallelogram law, the diagonal or this line defines the F A plus Fb. where you can see FA plus FB is in equal in magnitude and opposite in direction with the FC. So in such a case also, the net force at the particular point or the origin will be 0. In such a way, if you are considering n number of forces as like F1, F2, etc. up to Fn, then the net force will be 0, that is F1 plus F2 plus etc. up to plus Fn if is equal to 0. Then we can say, you can apply the first law of motion there. That means the net external force, if it is 0, then the body will remain at rest. Okay, it means the body will remain at rest or in uniform motion or in a uniform motion. Okay, so in vice versa, if the body is continuing in rest and or in a uniform motion, then the net force acting upon the body will be equal to 0. So that is the equilibrium of the particle. Now we have to discuss the common forces, and you just go through the textbook and you just read the textbook. And I have sent you one PDF in the morning. You just to go through that PDF also and study that PDF thoroughly. There are some important topics. Okay. So the common forces in mechanics, that video I will send you soon. So wish you all the best. Thank you.